Hello, hello.
Hey Mike, how's it going?
Pretty good. How are you?
Good, thanks. Thanks for joining.
Thank you for having me.
Of course, I'll give it a minute or so for other folks to join. Hopefully, I know a couple folks on the tag side are going to be possibly a couple minutes late. Um, we'll see if the other presenter joins as well. Is it just you from the OCM side today?
Yes, it's just me.
Okay,
And
great.
I am just setting up right now and muting everything.
Okay. Would be a sparse group today.
That's okay. There are a few folks that wanted to join, but due to time zone differences,
Yeah,
they weren't able to make it. I told them, the CNCF tag folks have been uploading quite frequently, so I mean they can just watch the recording from the YouTube, and it's
yeah,
fine.
yeah, for sure. If nothing else, we'll record and publicize to everyone else who can't make it live today. Um,
And we thank you for that because I know there's some communities that doesn't, upload as frequently, and we have to, and so we really appreciate you guys I mean, you folks were able to upload.
of course, we do our best to do that in a timely manner, because I know that's important to get that visibility out there as well. So Mike, we're four after. So there was another project. So I guess first of all, welcome to Tag-Runtime, bi-monthly meeting. So this is our first meeting of March. We had two presentations on the agenda today, NumaFlow and OCM. So we only have OCM here today, which is fine at the moment. So I suggest why don't we get started with you, and then I think some other folks should hopefully join while you're talking, but we might as well go ahead and get started since we're at four after here, almost five after. Um, Yeah, so I don't know if you have a presentation or it'd be great to turn it over to you.
Well, thank you, Steven, for having me. First of all, I'm gonna start sharing my screen. Just share my entire screen. Can you see my screen?
Yes, looks great.
Great. Okay, once again, thank you to the CNCF Tag-Runtime for having us. We are the Open Cluster Management project. Our GitHubs, our Slack channels on the screen. And I'm Mike Ng. I'm one of the Open Cluster Management maintainers. So what we really want to do today is give a status update on our project. When we were onboarded to CNCF about 5 years ago, we gave a tag one time presentation. At that time, our capabilities were quite good, but it's been our fifth year since we joined the CNCF project, and we just want to share our enhanced feature sets and our visions for the future. So first of all, what is open cluster management? Again, we're a CNCF project. It's fifth year in CNCF. It's mostly about multi-cluster, multi-cloud Kubernetes orchestration with vendor-neutral APIs. Our architecture is hub and spoke, and we design it to be modular extensible, which is really our key point is making other project becomes multi-cluster aware while using our core foundation. Okay, so that's what is OCM, and here's what we have done since we joined CNCF. Our stars and community engagement continue to trend upwards, which is nice. Adapters, contributors, and maintainers, we're steady growing, and we have been actively participating in all the major KubeCons events and other open source events as well. There are numerous integration projects with other open source projects. And one thing we've been continuing to do well is actually participate and lead in the Kubernetes SIG multi-cluster community. We lead the API design, and we also follow the API guidance while implementing our APIs to fully adapt the community's agreed standards. And then we also have tons of new feature regarding our core multi-cluster concepts, which I'll get into shortly, along with many different new add-ons and extensions, including AI-related enhancements. And then we also have been consistent deliver on our releases. We'll have another release coming up in half a month. Our current version is v0.15.2. So that's what we've been quite busy since we joined CNCF. And our future vision is just a quick overview where we're gonna do our major release, the 1.00 release soon. It's gonna be a major milestone marking the kind of like stability and maturity of our project. And then we're also trying to advance to the CNCF incubation status. We're working on the application right now. And then again, we're going to continue to lead and participate in the SIG multi-cluster efforts, driving that API maturity and really lead and follow the community centralization. And then again, we'll continue improve our core multi-cluster concepts, which is cluster inventory, work distribution to those cluster inventories, and then content placement, which is the scheduling of what work goes into which cluster inside the cluster inventory. And then we're gonna have to continue to introduce new and enhanced extensions. The few highlights is the federated machine learnings, and then the Argo CD agent integration. For greater flexibility and scalability for ML as well as the GitOps tools and all the other new add-ons and integrations as well. Okay. So once again, I want to quickly highlight the OCM architecture. So the OCM architecture is hub and spoke in its core. We have mainly the hub cluster, which is the OCM control plane or the multi-cluster control plane. And that's where you have your cluster inventory it lives in. And then you register you register your managed cluster from the spoke side. And then in the spoke side, you'll have your OCM agent clusterlet deployed there. And then if you have additional add-ons, it will be deployed on the spoke as well. So the managed cluster is always pulling the desired states from the hub to the managed and reporting the health status back to the hub cluster. And then these are just core components. We have the registration, which is registering a new cluster into the hub cluster for multi-cluster control plane to control. And then again, we have the work delivery, the manifest work. We have the placement, which is scheduling of what work should go into which cluster. And then we have our add-ons. So we provide a few native add-ons. It comes with policy, application lifecycle, and cluster proxy. But there's a whole bunch of other add-ons that anyone can feel free to explore. And we also provide a add-on framework that you can design and create your own add-ons as well. So I want to go through some of the improvements that we have made to our core concepts, which is cluster inventory, work, and placement. So these few slides, we will talk a little bit about what those core concept is, and then I'll talk about the features that we have made over these 5 years. So cluster inventory, it's about managing a bunch of clusters inside the inventory. So that deals with registration, and then it's mainly the pool model as I explained. So once again, we have the hub and spoke architecture. And what we have done on these few years is we adopted the Kubernetes SIG multi-clusters above API. We So the SIG community have been less about providing a multi-cluster tooling, so to speak, and then it has deprecated the Q Federation, and then the SIG has been about API driven, so providing standardization and have other project implement those API. And Open Cluster Management is one of the implementation of those standardized multi-cluster API. And one of the API is about API, which is cluster claim. And then we've been supporting. We're gonna have support. We have support for EKS as a hub cluster as well. This was a little bit tricky because EKS does not support some of the feature that we use for registration, but we now have that support. And then again, we let the SIG-MC Sigmoid cluster community, and then we were able to create the cluster inventory API project under the Sigmoid cluster. And the cluster inventory API project is essentially align our OCM managed cluster, which is our cluster inventory, to the SIG-MC's cluster profile API. And then the next core API is placement. So placement is a bit complicated because it's a scheduling, it's an orchestration tools. So placement is able to select based on either predicates or prioritization or amount of resource available, and then it really picks and then it chooses the best decision uh, for your workload to be delivered to. So there's an input, which is the predicate, the prioritization. You sort of want to list out your desire scheduling desire, and then it comes out with the decision based on those desire. And then consumers of the placement can consume the decision, and then whether it is observability or whether it is workload delivery, and then based on those decision, implement the desired outcome that way. And in terms of this concept, in terms of this core API, what we have done is similar to native Kubernetes project. I mean, the core Kubernetes project, we added taints intolerance, which filters out unhealthy or unavailable clusters, and then we also support maintenance mode. And then we also added a score-based prioritizer. So which means that each managed cluster can have their score fluctuates, and then if a score is higher on a particular managed cluster, the scheduler might pick that cluster over the some of the other lower ones. So that is driven by the add-on placement score. It's there's many implementation that you can do with the add-on placement score, but a particular really hot area is using the external data such as CPU, and I forgot to mention right here, really importantly, the GPU, you know, which really allows for those AI workload scheduling. And then we also have decision strategy, kind of group the cluster into placement decisions instead of just one giant long list, kind of group them together. And why that's useful is maybe you needed to do some rollout strategy, which we also added in placement. So this allowed workload to apply progressively, because when you're maintaining your fleet, not every you might want to have your some of your fleet of clusters be progressing first. Maybe it's from staging environment, and then you want to do the QA environment, and then you finally move on to the production environment. So we also have the OL strategy added into our feature set. Okay. Now, the one of the last core concept of multi-cluster for OCM is workload distribution. So this is what we use is we call it the manifest work API. So manifest work API, to put it simply, you can imagine it kind of like an envelope, and then you put resources, which is the work that you want to deploy onto the managed cluster, into that envelope, and then you kind of send out that envelope, which enable distribution and management across multiple managed clusters. So there's a lot of features and enhancements that we've done in the past 5 years for this API. Again, we fully implement and also lead the SIG-MC in this API. And on the SIG-MC side, it's called the Work API. And then we added status tracking, which tracks the the work statuses and report back their health automatically back to the hub for overview of the fleet-wide overview of your workload distribution health. And then we added garbage collection to make sure we don't leave behind any security sensitive resources behind. And then we layer to garbage collection. We also added delete option because sometimes admin or user will want to leave behind some resources when delivering the envelope, but just leave behind the resources. And then there are situations where when we deliver work, there are other stuff that's also using the work at the same time, which kind of create this waste and adoption conflict scenario. And we are able to add features that are able to handle that. So it depends on the use cases, but we added options for the users to adopt. And then another key thing is dynamic identity authorization that we added. So we added the executor subject to make sure the executor actually has the permission before applying those workloads. Okay. So now I'm gonna go into a really hot topic, which is AI workload scheduling, and this fully leverage everything, all the core concepts that I talk about, right? The cluster inventory, the placement, as well as the work delivery. So we can, yep.
This,
Sorry, go ahead.
this is what Ricardo wants to hear, all about the AI.
Yeah, yeah. So before I continue, I really should have taken a pause because I didn't hear anyone joining or anything. Are there any questions?
It's
I'm gonna
just
take.
it's just us, but the meeting is actually recorded. But I don't have any questions. I don't know if you, Steven, you have any questions?
I have a few questions, I guess. Yeah. Maybe before we move on to the AI centered folk. No, I'm just kidding. Um, yeah, I guess when you talk about workload scheduling, and the cluster management port, are you creating provisioning clusters as well as scheduling workloads?
No, we are not. We have integration with cluster provisioners, such as Cluster API, but
Yeah.
we are not the provisioner of those clusters. So we would want those clusters to be already created and then be registered and then use OCM to register those cluster into a cluster inventory.
So
Yep, sorry, go ahead.
when you say you work like with cluster API, is that something that OCM can initiate a create through cluster API or through, standard mechanisms, or you expect those clusters to pre-exist?
So when I say integrate with API is someone will be using cluster API to create a cluster,
Okay.
will provision a cluster, and then we have integration on our side to automatically pick that up and register that created cluster into our cluster inventory.
Gotcha.
So we will not be driving the provisioning, so to speak, but we'll be integrating with it.
Okay. So someone would provision and manage their clusters however they like, cluster API commonly, right? Across different cloud providers or whatever. And then as part of that provisioning step, it would register back to OCM.
Exactly. And they I think it's fairly obvious why we didn't tackle the provisioning problem because there's already quite a few projects in the community, right? Cluster API being one of them. On the Red Hat side, there's Hive API as well. So we didn't feel the need to overlap with the existing project. Instead, rather to integrate instead and try to enhance the whole multi-cluster experience.
Yeah, totally. Okay, cool. Yeah, thank you.
I just want to ask, let me check the time. Yeah, I'm taking a lot of time. Is the other project in the call as well, or do I have time to go a little bit longer?
Nope. Yeah, looks like it's just you. So you can certainly take extra time for sure.
Sweet, thank you.
I have a question. So I I don't know if you really went through this already, but do you support like other clouds like EKS, so you can do multiple EKS management, different clusters and cloud providers? Oh yeah,
Yes. So one of the key things that I talked about, I need to go back to initial slide. We are cloud vendor neutral, and then or we're cloud, yeah, what's that right word? Cloud
agnostic.
agnostic. Yes,
Agnostic.
exactly. Thank you, thank you. So we vendor neutral and AKS, Star KS all works. We just have a little difficulty with EKS because of some technical challenges. But we have so we are building a really nice community because we have the external contributor that's contributing this big section of supporting EKS as a hub cluster. So we have EKS support as well. So I just want to take an opportunity here to shout out to the team at Guidewire for really driving this implementation and design as well. So thank you to the Guidewire team.
Yeah, that's great. Yeah. Um, yeah, so you do support like GKE and AKS and all that other stuff too.
Yes.
Uh, do you support like multiple combinations of this? Like a hub cluster can be in EKS and then the the other clusters can be in different clouds or in
Yes.
okay, yeah.
Yes.
Oh, that's awesome. Yeah. Thank you.
So before I touch up on all these other extensions and add-ons, any other questions? Okay. So I'm gonna talk about I put this near the front of the slides because it's a hot topic. It's AI workload scheduling. So there's a project in the community. I think it's also a CNCF project called a Cube that is about
Yeah,
scheduling jobs as well, and
part of
they
the
have
Kubernetes, it's part of the Kubernetes ecosystem, right? So
yeah.
I don't know if it's CNCF yet, but it's part of it's under Kubernetes 6.
Yeah. So we have been working with them as well, and then we actually present this in one of the QCon, and then what it uses is also take advantage of the SIG-MC cluster profile API, which is something we led as well in the cluster inventory API project on the SIG-MC side. So it uses OCM or slash fleet. Fleet is another new CNCF sandbox multi-cluster project. And then through the cluster profile, which is a standardized API, Cube is able to consume the inventory, and then based on the scheduling. In this case, in this diagram, it uses the OCM placement, and then the add-on placement score, the GPU available, kind of like schedule the workload down. And then inside the agent here, there's the score agent telling the hub which clusters have available resources to deal with these AI workload. So the first step is the resource usage collection, and then maybe yeah. So the second step is actually the applying the consume that placement decision, and then applying those resources, applying those workload directly. So and when I say multi-queue is their queue projects kind of going down to multi-cluster levels, putting on the queue, and then the job is actually wrapping those AI workload. So that is one of the example of the add-on. I have many more to share, but this is one of the shout out to the student um, from last year Google Summer Code that did this work. I think her name is Jisheng. So thank you very much, Jisheng. Before I move on to the next one, any question regarding this part? Okay. So we also did a lot of enhancement with Argo CD. So Argo CD is a graduated CNCF project. It's the primary GitOps tool, I should say. So we donated the OCM placement uh, integration into Argo CD. So if you go on Argo CD, the website documents, you can actually find this cluster decision resource generator. And this, what it does is allow Argo CD to fully take advantage of our OCM placement scheduling. And then so here I'm going to talk a little about something that's really exciting coming up in Argo CD as well. So Argo CD have been traditionally a push model. So you have on the Argo CD control plane, you talk to the Argo CD controllers, they connect directly to the managed clusters, and then they will apply the resources that way. So OCM is a pool model centric, and we have done some integration work with the pool model with the Argo CD agent. Argo CD maintainers as well. And then here's their new project. So they've been developing a new project with us as well. So this new project is Argo CD agent, and what it basically does is essentially provide a hub and spoke model instead of the traditional pull model, instead of the traditional push model to Argo CD. And then, this really a complex diagram, but essentially the OCM job here is to help the Argo CD register the managed clusters into the Argo CD hub, as well as maybe provide the secure communication as well as managing the life cycles of those Argo CD spoke agents. Again, details of this can be found on the Argo CD agent website with the integration with OCM.
Yeah, that's really interesting. I think a lot of the push from Argo can have some scale limitations, right? When you get up to like, I don't know, thousands of clusters, certainly. Um, do you have an idea of what you would like to scale to from being able to switch to the pull from the managed cluster side? What what are your kind of goals there, maybe?
No, I don't. I don't really have those Argo CD specific numbers on my hand, and I don't think it's appropriate for me to say those numbers. But generally, the yes, so there is so it is fair to say that there is some performance issue in Argo CD traditional push module, and that's because everything, all the clusters are loaded into this application controller, and I know there is some sharding that you can do as well, but essentially, it's not going to scale that way, and that's why the Argo CD maintainers were willing to kind of create a new project right now and sort of essentially push some of these workloads in the application controller, and then they're going to move it all to the spoke size.
Mhm.
So that relieves a lot of pressure on the Argo CD application controller itself. So
Okay.
the agent project is complementary to the Argo CD main project. It's definitely not a replacement.
Mhm.
So in this diagram, we can sort of see that. So on the hub side, there is no longer the application controller, which is mainly responsible for dealing with talking to the repo and deploying the resources and managing the health, etc. The application controller have been moved to the spoke side, and you can imagine there are many other managed clusters. So that is how, by delegating the workload down to the spoke cluster, that is how the Argo CD is hoping to be able to scale out. And I know I'm sorry, I'm not able to provide you with a good number, but I don't think it's in my place to
No, no,
to
that's
promise a certain number.
yeah, that's okay. Is this, you said, is this upcoming or is this currently available, the agent work here?
So the agent work is in preview right now. You can certainly go ahead and try it out. And same as is the same for the OCM integration with the Argo CD agent.
Okay.
So you can, I mean, not to sell myself a little bit, but I think the sell our project a little bit. I think if you use OCM to bootstrap the Argo CD agent project, is quite easy. So we have the all the guide or website description all there in the Argo CD agent repo. Hopefully, you can find it. If not, feel free to reach out to any of the maintainers in OCM, as well as Argo agent folks. Yeah.
Cool. Thank you.
Okay, I'm not the governance policy experts, but I just want to touch up on, we have a native governance policy framework add-on, and this really deals with configuration management and informing and enforcing Kubernetes manifests. So it also support dynamic templating, and then it includes integration with the popular project like Open Policy Agent, Gatekeeper, etc. So this is a little bit more details of the OCM policy. So again, this is an add-on. You don't need to use it, but it's there available for you. So you can see that there's some integration with gatekeeper. There's remediation action, means you don't want to inform or actually action on a policy violation. And then there's the templating that you can use, so which really helps with the multi-cluster management, because each management cluster is going to have a little bit of differences. So you do need you do want to have sort of like a templating style to sort of deal with those differences. And then I talk a lot about how OCM is primarily a pull model, a hub and spoke model. So we also provide the cluster proxy add-on with some other add-ons as well that will give you the ability to kind of reverse proxy. So going from the hub cluster and directly have access and as well as push down resources to the managed cluster as well. Again, it leverage Kubernetes 6 technology, and then it's an add-on as well, so you don't need to install this, and that really highlights the benefit of using OCM. It's quite modular. You can pick and choose the pieces that you like. And then managed service account is kind of work with the cluster proxy as well. So you can create some of these service account from the hub side, which would propagate down to the managed side. And then when you have those service account tokens on your hub side, you're able to do, for example, the reverse proxy things that we talked about. And again, this is another add-on. And then to wrap it all up, we have the Qvela integration, and that OCM really provides this multi-cluster capability to Qvela. And then the diagram's quite complex, but essentially Qvela uses OCM sort of adding the clusters into their own cluster registry, and then using OCM you can do the reverse proxy, and then it's Qvela. You can deploy Qvela app that way. And then there's a whole bunch of other capabilities that we have in OCM, because OCM, it's when we start off, OCM is deployed into a hub cluster, right? So each cluster either have OCM artifacts or it doesn't have OCM artifacts. But then in some cases, you don't want the agents or even the hub components running on the clusters that you are managing or the manager of those clusters. So we provide like hosted mode, where you can sort of delegate the OCM aspect outside of the clusters that are being managed. And there's some advantages to that, so you can keep the managed cluster that you're managing clean. From a general look at the cluster that you're managing, it doesn't actually have any agents, so you can sort of, maybe it's easier to pass the security compliance because there's less CRDs deploy onto the managed cluster. So we have different kind of hosted modes, many different scenarios that you can sort of use. So it depends on your needs.
So for the hosted mode, so in that cluster 1 there, it's you can act on it through hub 2 and 3 directly. You don't need the agent for those hubs, right? Does that also then, can you also leverage connectivity in that case to reach out to the hub to allow it to initiate, or do you have to have the API server accessible?
So you're saying if the agent is not on the cluster 1, the managed cluster itself, can the connectivity still reach out to it? Is that what the question is?
Yeah, I guess in
Yeah.
the diagram there, like hub 2 is reaching out to the API server, right? So that has to be allowed. Can the cluster 1 open that same connectivity tunnel that worked on the previous slide in that way, or does it have to open the API server? I'm sorry, maybe not the Kubevela one. This one, yeah.
This one, right? So I don't know. I'll need to get a look at the specific, but generally it should be able to, because when you're deploying the agent is, oh, but in this case, your agent is not talking to the Q APIs. So when we're registering in cluster agent and a cluster and an agent that's running in a hosted mode, both still requires the kubeconfig to connect to that cluster. So the agent is still talking to the managed cluster. So in this case, yeah, I understand what your question. Yeah, but then you have to tunnel through. I don't know. I honestly don't know, because maybe we haven't hit this question yet, or we haven't tried out that yet. But yeah, it's definitely something that worth looking into. I sort of understand.
Okay, because I think the advantage of the hosted mode then is you don't consume resources in the child cluster or the end cluster there, right? And then but you can still
Exactly.
manage it and get the benefits.
Yeah.
Just the question is, can that still be like remote or firewalled and still allow the management to occur?
Yep. Exactly. Yep. So speaking of the firewall, that's also one of the reason why we decide the OCM to have the hub and spoke as our core architecture, because in hub and spoke model, you just need to have the hub API server available for access. So all the managed cluster are connected to that, versus the traditional push model. You might need the many more managed clusters be open. So that was also one of the main motivation. No, that was a great question. So thank you for that. I'm gonna look into that as well.
Cool, thank you.
And then multi-cluster control plane. Oh yeah, this is also another side project. Right? So we talk a lot about running OCM in the clusters, or even in hosted mode is running on another remote cluster, whatever. But what if you just want to run OCM without clusters at all? So that's where kind of multi-cluster control plane as a side project comes in. It's really about reducing the OCM footprint. You can kind of think of it as a mini OCM, and then you can even launch it as I said, standalone binary without deployment on a Kubernetes cluster. So what kind of benefit it provides is, multi-tenancies. So you can have multiple OCM hubs in a clusters, and each inside a name inside their individual namespace. So those namespaces essentially becomes the multi-tenant tier. And then why is that good? Because a single cluster with multiple OCM instances can actually support managing more managed clusters due to the etcd limits. So if you have a cluster with OCM hub installed, you probably hit a limit on a certain number of managed clusters. But if you have a hub, you have a hub cluster with many different in many different namespaces with this multi-cluster control plane, mini OCM in each namespaces, and each one of those manage a certain amount of managed clusters. You total that up, it will actually exceed the traditional deployment. And then another benefit it comes for platform compatibility, right? The issue we talked about EKS before. One of the way to get around is using multi-cluster control plane. That was before we have the native EKS support, but now we do. But again, this when you run something in sort of a container fashion like the OCM, you're gonna get a lot more compatibility than just running directly on a cluster. So that's another project that we have available for users to consume. Again, it's optional; it doesn't come as a mandatory thing.
And by
So, yep,
just quickly, by multiple OCM instances, you mean essentially one cluster can act as a hub to many, like there's many different hubs on running on one management.
yes, exactly. So it's kind of like a hub of hubs in that case, right?
Okay.
Yeah.
Yeah, cool. Thank you.
And we're kind of fortunate that the other project weren't able to join because I did take quite a long time. So just want to say thank you again for the CNCF Tag one time for having us, and your hopefully I gave a brief status report on what we have been doing for a few years. We have a lot more exciting stuff, and for any of our viewers, feel free to connect with us in all these options below. So thank you very much.
Absolutely. Thank you, Mike. Um, would you mind sharing the presentation slides? If you can put them right in the meeting notes, if that's easiest for you, just put a link in there, and then we can make sure to get those shared out as well. And will help for future folks that are looking to look into this as well.
Yes, absolutely. Thank you so much for that.
And then I guess just you say you're advancing towards incubation. I assume that's 1.0 release first, and then work towards incubation from there.
Absolutely, yes. You're correct.
Okay.
Okay, I'm gonna stop the sharing. Assuming I know how. Okay.
Great. Yeah, well, thanks so much, Mike. Please reach out in the channel if there's anything else you want to talk about. If you have an update as you get closer towards incubation and there's more you want to update for that process, feel free to come back and get on the schedule for updates you want to do around that time.
We will take you up on that offer for sure. Yeah, great.
Anything else from you, Ricardo?
Yeah, I think you already asked about incubation, so yeah, let us know. And also, if you have any items that need clarification, feel free to ping us on the Slack channel, on the Tag-Runtime CNCF Slack channel.
Will do. Thank you.
Yeah.
Very good. Thank you very much, Mike. Really appreciate your time and all your presentation today and all the information. Thanks again.
Thank you. Take
You.
care.
Bye.
Take care.